Hello, thank you for joining me. So in this series of videos, I'm going to be showing you how to set up a part drawing and some of the little details that go into that. We're going to be emulating our engineering design book, project number 3 in this, but we're going to be using our own parts. We're going to go a little bit beyond the book. The expectation here is you've already done some of the stuff in the book, and you know how to do this, but sometimes the book isn't really as clear as maybe putting together a video. So that's what this video is going to show you. It's going to show you how to do a lot of little things in regard to getting our model into the drawing, and of course putting annotations in there like our dimensions and other similar items in order to get a drawing that can be quite literally handed off to somebody so they can fabricate it. And as I mentioned in class, and this is a test question, by the way, this is a test question. You want to make sure that you know that drawings are probably the most widely used way of demonstrating your design intent to other people. It's a way of being able to fully document as best you can, the information you want on a part that you want somebody else to fabricate. And that's the purpose of drawings. And we've gone through a lot of things like Photo View 360, and we talked about the Motion Manager and some other things in regard to demonstrating our object. But drawings are traditionally the most well-used demonstratable object that you can give off to somebody in order to have them fabricate that part. So what it does is allows you to take, just like it's always been that way, to take your idea, put it down on a piece of paper, and give it to somebody for them to build for you. So we want to make sure that we kind of follow the basic standards that are associated with that. And a lot of this stuff is set up automatically in SolidWorks, but there are things that you need to do when you put your drawings together in order to make it look and function correctly, and that's the nature of these videos. Whew. So that's enough said there. So let's go ahead and get started. I put in my 3 standard views. I think you know how to do that. We have our front, we have a top and a right view. When we put in the front view, typically it'll allow us to do the right view and the top view, and I think I demonstrated this in my bill of materials drawing. Now we have our isometric view too, which comes in. Now our sheet scale. Something you need to keep in mind is right from the beginning, let's just get a proper sheet scale. From these views that you see here, I'm going to be putting in some additional views like a section view, an auxiliary view, and a couple detail views. And we want to make sure we have enough room. So 1 to 10 scale, which is what it comes in here at. And I know that if I go to my title block and see what my scale is down here, they kind of put in a scale of 1 to 10. That may not be appropriate for English units, for Standard American English units, SAE units. So one thing it will give you an opportunity to read up on, and it's a kind of compilation of my experiences and some information I found online and in the book. I put together in the Student Resources section of the website. Bang, we'll bring that over here and show you that. An area on the Student Resources section of the website called Drawing Guidance. Tells you what you need to do in order to, in a very general way, to get a decent grade in class in regard to your drawings. And more specialized, or maybe generalized grading criteria comes down here. So you might want to read this through, but there was one thing I want to show you here, and that is this section here on scaling. Metric scales are typically like 1 to 1, 1 to 2, 1 to 5, 1 to 10, and other similar multiples in regard to 1 to 2, 1 to 5, and 1 to 10. Typically are multiples of 10, or 5, or 2.5, or 2, which is typical for metric. Standard American English is more fractionally related. So 1 to 1, 1 to 2, 1 to 4, 1 to 6, not as common, 1 to 8, 1 to 12, 1 to 16, and so on and so forth. Typically those are multiples of 2, 4, and 8. So those are things to keep in mind. So we have a 1 to 10 scale, which probably would be appropriate for metric. Not as appropriate for English, since this is in English units right now. So I'm going to choose a different scale, a similar scale. So I'm going to make mine just a little bit bigger, so I'm going to choose a number that's a little bit smaller. So scale is like the reciprocal of the scale factor. Right now it's 1/10 the size of what it would be in real life. And the way you read that, and that too is a test question, the way you read the scale, like maybe the scale of 1 to 8, what that means is that 1 unit on your drawing means 8 units in measurement on the actual part itself. So the first number is for your drawing, the second number is for your part. So if we read a scale like maybe this 3 inches equal to 1 foot, a 1 to quarter or a quarter scale or a 1 to 4 scale, that means that 3 inches on the drawing is equivalent to 12 inches or 1 foot on the part. So SolidWorks kind of defaults to this 1 to 4 or 1 to 6 or 1 to 8 scale. What's more or equally common in engineering drawings are the 2 inches is equal to 1 foot, 1.5 inches is equal to a foot, or 1/2 inch is equal to a foot, or so on and so forth. Those things are also common too, so we're going to kind of stick with the SolidWorks format and not change that. So we are going to choose, for this drawing, a 1:8 scale. Choose an appropriate scale per the guidelines here for your own drawings. So we'll move that out of the way. So when you do that is you right click on your sheet, over here in your Properties Manager, go to Scale, go to Properties, and then you can go to Scale. So the sheet scale is going to be, instead of 1 to 10, it's going to be 1 to 8, and then go to OK. So we can go over here to Properties too. That will give us the same information. We go to Sheet, go to Sheet Format, it's the same element here. So we can open and close that as we see fit. So now if we go down here, now our sheet scale is now 1 to 8. So typically the item that gets inserted first, which is usually the front view, that's the one that sets the scale for the whole drawing. So if you want to change the scale for that view, it'll change everything. So here's a third alternative to doing that. You can go to the sheet or sheet format, or go to that front view and change the scale here too. We're going to use the sheet scale here, but if you're going to do a custom scale here, let's just do something like maybe 1 to 6, 1 to 4. It does change the scale of all the other views that are associated with it, since that's the first view that went in there. So let's go back up here to sheet, go to our properties and see what our sheet scale is. Still 1 to 8, which means that any additional item we add in there, it's going to initially put in there at a 1 to 8 scale, but we could change that to 1 to 6 too. Doesn't change anything on the sheet, but now it changes our sheet scale down here as it's viewed on our title block. So let's take our sheet scale, change that to 1 to 8. Again, no change here, but now if we go back to this view, or click on that, and now we're going to use sheet scale for that. Green check mark, and we're right as rain, we're right back where we should be. A couple more things I want to change here too before we leave this video and go on to the next one. Let's take some of the views that we have here and get the right display state. For our isometric view, we want to make sure we do hidden or shaded with edges. For some of these views, we want to kind of see what's in the background here. There's 2 different tubing sizes here. So if we click on maybe the front view and go to maybe hidden lines visible, because that front view kind of drives these 2 other views over here, these also are going to be hidden line visible. If we want to make this to maybe only hidden lines, like the way it was before, we can change these individually. And we're probably going to change these back a little bit as we go through the rest of this exercise. So I think that's enough for this video. I'm going to stop here and we'll pick this up in the next video.